Hey guys, it's Rich from Art Smart.
What's going on here?
Hi guys, Rich from Art Smart. Welcome back to another YouTube video. So today we've just been down in Surrey with Hudson Lighting, filming a podcast. Shout out Hudson Lighting. You might have seen Chris from Hudson Lighting just before this intro rudely try and mock my intro. I'll let it slide. So yeah, I've been filming the podcast. However, I've actually known and spoke to Chris for a lot of years. However, today is the first time I've met him. So our podcast, well, when it does come out, it's probably going to be the longest podcast of the series. It has been hours. So it's actually out of hours now. We've sent the boys home, but Chris is going to show us around actually making some of their fittings, because they do the full design, manufacture, shipping process in here, including all the electronics. So let's go find him. Oh, just here like by magic. Chris.
Just pop through the corner.
Chris, talk to me about your workshop.
Of course.
But before, I'm intrigued by the computer that's here.
Yes.
Is this how it all starts?
It is indeed. So we're doing design both upstairs and downstairs. So basically we've got Fusion 360
It's just showing
running.
off who's fancy. Is this a sit-stand station,
yeah,
Chris?
Exactly. Oh, well, I'm standing, aren't I?
And
you're standing with me, so I've got to bring it up. Hopefully
Yeah.
the charger doesn't fall off. So we've got Fusion 360 running on here, and we've got a few parts. So we've been machining wall light bases on the Nakamura, and we're doing spotlight tops on the Haas.
So you've got CNC lathes in here.
CNC
Come and have a
lathes,
look.
absolutely.
This is an engineer's paradise. We've got his existing lathe, his Haas lathe, and then we've got the new one here, the big dog. Talk to me about them.
Okay. So the Haas CNC lathe we got originally, we had in a garage. It's a single phase machine, and of course we had to have single phase because it was a domestic garage, and it was the biggest that we could get in there really. I mean, it doesn't look that big from here.
You got it.
It's actually quite deep. And you've got all of this hanging out the back end, and basically what you can do is you can feed a long piece of bar. Oh, I'm just grabbing the whole stack. Long piece of bar, like one of these, essentially from this bar pusher, and it will just keep repeating to make part after part after part. So today we've been running spotlight top, so that's a spotlight top that we've been running. So the first part of the process in this is that spotlight top comes out, it needs to be reamed and actually checked over. On the Nakamura, we're normally running a lot bigger parts. So we're running things like these sleeves that Rich has got here. We've been running wall light bases as well. Sometimes we do some of the smaller stuff too. It kind of depends on what we need capacity-wise and what's spare and what's
This all comes out threaded?
Yeah. So we've got to be done all in one hit. We want to have the least amount of processing possible. So
Processes.
Yeah.
So it says processes. I don't know if you can see these boards, and you'll see them everywhere. So why do they have these on here?
to save time. We've got homes for tools. Can you imagine what happens is someone comes in and goes, yeah, I'm going to use this tool, blah, 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 and I'm going to put it down on here. And I come along and I'm like, right, I need to use this tool. Where's the tool? Where is it? And you spend, you know, sometimes you can spend 20, 30 seconds, sometimes you can spend 20 minutes looking for a missing tool.
Easy.
So by having homes for things, we know exactly where they belong, they go back to the same place, and we can easily find it.
This is cool. These tablets are all around the building. Now, you have to watch the podcast for more detail, but basically, Chris has coded up his full website and his own custom ordering software, which is all run through here. The software, machined and measured parts, is then recommending what parts this machine does next.
Absolutely.
That is seriously impressive. And the powder coat station that we're going to see shortly does the same.
Exactly that, yeah. So it's just trying to help the operators know exactly what they need to do next. The other thing that we've got going on is that we've got these parts trays essentially telling us what stock we need to build. So each are labelled. These are basic in trial at the moment, but essentially they give us the count, they tell us what we're doing to green spike tops, and they process through from the machine inside through to anodise and through to powder coat. So I've got a spike top. So first part of my process, when I'm hitting certain levels on the actual plate, is that I'm going to actually measure the parts and make sure they're in tolerance. So I'm meant to be 21.04. I think that's pretty well within tolerance. We do plus or minus 0.1, and it's 21.06. So we're pretty happy with that. So from there, from processing parts, we come through and we come into our anodise section. So the idea is that one of the guys is meant to load up these jigs. These are titanium jigs. And the reason we use titanium is that basically they don't actually anodise. So you can use the jig over and over again. It does eat the copper a little bit. You kind of see the copper hook's gone a little bit, but yeah, it's and it's in hydrochloric acid. So it's a 11% strength mix between hydrochloric and water. Basically goes on this copper bar, and we flow electrical current through. There's a lead cathode on the other side, and that creates an anodised layer which hardens the outside and makes it that if you wanted to, you wouldn't have to powder coat these. You could have these outside just as they are, and they wouldn't corrode for a long, long time.
Nice.
And aluminium's already pretty well corrosive resistant anyway. We buy 6082, which is incredibly corrosive resistant.
Nice.
So from there, we powder coat. I'll take you into the powder coat area. So I've got air now blowing down the sides here. So literally, there's no issues with regards to dust or anything like that.
So yeah, leave that in the oven then.
Yep.
So that's going to cook the parts on. Where we're going next?
20 minutes. Let's go up to the assembly area.
So we've come upstairs now, and this is actually their assembly area. So this is where electronics are made.
Yep.
And then parts are assembled. Now, because it actually takes too long for us to make the electronics today, but it's effectively LED in the circuit board.
Correct.
We're going to come over here and assemble one that's already been made up.
So we've got we're going to do a quick one on a planting light, just on the top section. So here's a planting light back. Basically what I need to do is take a protection circuit, which is one of these, and this is what we've already
pre-potted LED circuit.
Injection moulded and made. So I've
got the injection moulding machine over there as well.
Correct. Right, so we've put our protection circuit inside the body, just up to there, and our O-ring is going to go on the outside of the protection circuit. That is our bottom seal of our light. So that essentially is what seals the lower half. Little spray of silicone, and that just pops right inside there. We've got a 20x15 O-ring that goes on the outside. Again, little spray of silicone just for a little bit later. And
silicone spray on O-rings actually is first class, and it creates a very good seal, as I'm sure you know. That's why I use it. When I used to do diving and stuff, we used to have to lube up all our O-rings with silicone grease, and obviously we was going under multiple bars of pressure under the sea, and that was all good. Yeah. Well, we learned a while ago, so we used to use nitrile O-rings, and didn't realise that nitrile doesn't breathe, and you need something to breathe to deal with the heat differences between outside and inside. So I've placed the thermal paste inside the body there, and I'm just going to now do the heat sink plate, which is basically something that's designed to help adapt the LED heat into the body. So we just place that down there, just rotate that a little bit more, and then we take our LED, and I'm just going to Okay, so we've got our paste now on the back of the LED, and then we just take our LED. What paste is it? It's another thermal interface paste. This one's a little bit thicker, just to allow for more heat transfer between the LED and the body. And then we basically insert the LED into the protection circuit below. It's just 3 pins plugged into 3 sockets. Super simple, so it's easy to change an LED as well. So the Hudson Lighting lights actually have a replaceable LED chip. So for whatever reason, this is the only part within the light that can be blown up. If this were blown up by wrong driver selection, accidentally putting mains power to them, guilty as charged, then it's going to blow this circuit board up. Yeah, and eventually, you know, when it comes to the end of life, it can be replaced. Right, so we've got our LED now in the ball. We have a little 3D printed separator plate. That's just to separate the electrical components, because now we actually machine the reflectors. They were made of aluminium. If you had the aluminium sitting on top of the 3 pins, obviously it contacts the 3 pins and causes the whole thing to short out. So we have to have that separator plate. Now we have a 70-degree optic, pops on top of there. And I'm just going to pop that inside this holder just for a second, just so it doesn't go anywhere, while I take our top and our body and just place our 2 O-rings on top. Another little spray of silicone. And then that just pops in there, and that becomes the top seal of this planting light.
I can take our little M10 threaded insert here and just thread that on the bottom so it's ready to go on the rod. So that's got to go through the body. Okay. So next step is for testing. So we'll come over to our little testing station. Right, so I'm just going to confirm that the LED is working. So I'm going to plug this in, and then in a second it's going to come on. There we go. There's our white LED on. So then normally what we then do is put this in the tank at the bottom and leave that to test for an hour.
Right, leave them in the water for an hour?
Yep. Well, once it passes, it finishes its assembly. So we've got a long rod that needs to go on there. So if I pull that out as if it had passed. So next we actually screw this bowl onto the acrylic lens. So the last part of this light is that it actually has a rod that screws into the bottom, which is over here. So there's our rod that screws into the bottom. There we go. And that's how it would look.
Nice. So that's just designed to light the flower bed slightly.
Exactly that.
Come back up. So it's got no direction light. You're not going to get any glare.
No.
But just sit nicely.
Yeah, it's just a 360-degree beam angle. Comes down and does all your lower planting, like lavenders and ferns, etc. So from this, we actually then pack with all the bits and pieces that we got here for our packing station.
Cardboard.
Yeah, all cardboard, so we don't use the plastic.
No plastics.
Yeah, exactly. So this is literally just hemp. So, you know, you just bin it. And then we actually reuse any plastics, etc., that we come through our door. So we close this up and then wrap up the bowl and package that away. It has a product label that goes on there. So these are like the product labels that we have that just tell you what the product actually is. And there's also an advice label about how to do the installation, and then finally delivery note on there.
Because I assume that is your most common problem. As a constant current lighting manufacturer, people wired in parallel rather than series.
Correct, yeah. We had a garden only recently that actually was all wired in parallel. They put the video up on Instagram and I saw it and I said to them, those lights don't look quite bright. I think you've got it all wired in parallel. And 3 weeks later, they come back to me and said, yeah, it was. So
look at that. Look at that eye for detail.
Yeah.
Well, Chris, thank you very much for taking us on the journey.
No worries, mate.
Appreciate it, brother.
Thank you.
I'll take this one with me.